Well, we'll get into it. We'll go to Tomas. It is, as we were saying before we started, it's very late, and you've got a new baby, so sleep is important. Um, so you come from us. You're an independent consultant, architect, developer, trainer, and speaker. He has given talks at over 100 events across Europe, over 100 developer trainings in JavaScript, TypeScript, Angular, and React, and other tech. He's also the creator of ANF Training, has over 3,500 participants. Former React-oriented architect turned Angular enthusiast. So welcome to the dark side. Recently an Angular dev
Or the
tools
bright side.
contributor. Yeah, that's true. That's the bright side. He's a recent Angular DevTools contributor. So if you're using DevTools, you used some of his work. The co-founder of the Angular Tech Radar and in love with the Angular community. So welcome back. We had you back in April, I believe. You gave a talk here.
Yes. Yes. Welcome, everyone. So the title is Get Rid of Impossible States and Make Your State Predictable with State Machines. So the motivation behind this talk is that actually what I want to kind of introduce to you, or maybe remind you that you already know about that, is kind of a very I find it very simple, a very simple pattern that is very underrated, and I can express how much I think people should be using it way more often. And I'm not really sure if it's because of kind of misunderstanding or maybe a little bit of laziness in just overusing primitive data types all over the place. But I really hope that I will encourage you to either give it a try or basically remind you that it is really worth to give state machines a try. So this presentation is actually, this is not going to be a presentation. I prefer to introduce patterns via live coding. So I hope that you will enjoy it more, because this is going to be something that we will all witness how it's being kind of introduced to us. So let me just refocus and resize the windows here. So here I've got a very simple, very small application in which I've got a listing on a certain page. So here we've got just some tabs over here. So I'm heading to the employees tab. And here, let's imagine that we have some human resources application with some CRUD operations: create, read, update, delete. And here we have a listing of employees. And the API basically returns 50 elements per page. And this is the list of objects that we've got here. Some folk with a name, another people with another name, another person with yet another name, and so on and so forth. So this is a component that we are displaying over here on the left-hand side. And this is the TypeScript class. This is the HTML. It has already been migrated into the new control flow that we can use since Angular 17. And what I would like to kind of migrate, shift, what I would like to use it for is to highlight some potential problems, potential issues, and how we can deal with them, and what's the basically whole point of using state machines. What are the bugs that they can reduce, or kind of not even reduce, but ultimately remove entirely. So the starting point for us is that we have a employees stream that basically uses some employee service that performs some HTTP GET request and grabs some of the employees. And when we've got this observable of employee object array, then we basically can use the async pipe. So there is nothing actually interesting at this point. So let's say hypothetically that for some reason what we want to do is actually to process or basically handle the asynchronous part, kind of process the stream here on the component side, so not on the template async stream. So what we're going to do to everybody is to head towards more or less this direction. So before we do that, we would need to represent what is the state of our component. And just to make things clear, Data loading is one of the simplest examples of state machines and basically of the whole concept. And there are two reasons that I'm using this one. One is, first of all, basically in a limited time, basically this example fits this amount of time that I have here. And the other one is that in such a such a simple example, we will see pretty much all the bugs and all the benefits and potentially also all the costs of the whole pattern. So I hope that even though this example is slightly simple, you will be able to clearly see, and I'll be able to clearly outline what is the whole point. So the very standard data loading that we're going to deal with is basically that. We need to have some data, and in our case, we're just going to call it employees because that's basically the type of the array element. So we also need to show in some way, like we can see the circles moving here, like the spinner, the loader, whatever we call it. So whether something is loading or the data is still being loaded or not. And finally, some type for the error. Let's say that we could like use a string for that. I prefer to use the error itself because maybe in some circumstances we would like to know what is the error message, but maybe what is the error stack trace, etc. So just keep the native thing that has been thrown. So let's think about how could we represent the thing, because in state machines what we're going to do is basically to actually get rid of what we call an anti-pattern that is called anti-pattern, that is called a primitive obsession. So a primitive obsession is a pattern, as an anti-pattern, where instead of putting some more effort into modeling our data, we basically stick to a primitive Boolean, a primitive error. Like, actually, I know an error is an object, but the thing is, we are lacking the design here. That's the primitive part over here. So we'll be moving away from this into a state machine at this point. So here TypeScript is yelling at us that we have no initializer, and we basically need to assign some initial value over here. And yeah, that's the let's say problem or the challenge here, to think about what should be the initial value. So something that would be kind of it would make sense is to actually make the property optional, because, well, what should be the initial value of an array that hasn't been loaded from the server yet? So I would say assigning it to null or undefined actually does make sense. What I see the most often out there in the wild while doing trainings, consultancy, etc., is that people assign it with an empty array. So, well, there are certainly some situations in which this is correct, but actually this is a kind of shorthand for not thinking through what should be the initial value of the employees, and or whatever the data collection is here. The issue with the empty array here is that in some edge cases, it would be difficult for developers or for basically the code itself to differentiate whether this is basically empty, like there is no data yet because we are only initially displaying the component. This is one possibility. And the other possibility is that, let's say, we're trying to filter people who have XYZ name, and there is basically nobody who will have such name, but that would be a valid HTTP request, and we would basically get an empty response. So how could we differentiate having never any response at all and basically having a valid response which is just empty? So this is just an example edge case, is that if we don't think through like what does a certain thing actually represent, then we can create impossible states, and hence yet again get rid of impossible states using state machines. So this is something that we want to do here. So creating the initial value is one thing, and yeah, for the loading one, most probably we're going to initially load the thing. And finally for the error, yep, again, what should it be? Let's say that in this case, we're going to just provide a optional property in this very case. So that's basically a shorthand for defining it as the property that gets assigned undefined. Now, what is the problem with this, and why am I kind of criticizing this approach? Is that, dear everybody, we have 3 independent properties, and this is, in this case, let's say, the root of all evil. Now, they are independent properties, but are they technically, but are they logically or domain-wise, are they independent? The answer is no. And what states could we actually have in this case? Let's say that I'll basically get rid of here this loader so that it will basically will not show up all the time over here. So let's say that initially we have the loader, and if we successfully load the data, then we basically show the data. So let's say that loading would be one state, showing the data would be the other state, and finally, if something went wrong, then we would display the error message. So let's say in the most basic scenario, we would have 3 states. Of course, if our UX wants to improve this design, for instance, we could be loading data using multiple requests. So we could be displaying the data that we have loaded already, but we could be also loading the further resources and the next pages, etc. Here we're just loading the first 50, but maybe we wanted to display a longer list and create a, let's say, virtualized table, virtualized list, etc. So there might be more sophisticated cases, but let's just keep it simple and let's make it just 3. So if we are loading the data, so initially, let's say this is our case. We're just loading the data. We have nothing yet. What should be the correct value of the employees or the error? In this case, if we have the error which is undefined, this is cool, this is okay. But how about employees? Now, logically, how could we say what are the employees' value if we don't have the response, if we didn't receive the response? You could say, okay, just don't use it. Well, true, but bear in mind, this is a quite simple use case. And we'll see that even in simple use cases, people do make mistakes because in this approach, we are responsible for managing, like changing and reading the values of all the properties at each point in time. And that's the problem, right? And what I want to say here is that if we are loading, then we should not be even thinking about what is the value of the employees. It should not exist. And I don't mean it should be null or undefined. It shouldn't be there at all. So that first we would have to find in which state we are. And if we are in loading state, basically, the data doesn't exist here. How about the error? The error also doesn't exist here. So the thing is, everybody, if we create the loading state, and let's just make it a very simple type, which includes some generic type, what we can create here is, a Copilot is already suggesting me what I should put here, is that if we are loading, then what should be the data here? Well, no data whatsoever. What should be the error? Again, no error whatsoever. Okay, so if we have successfully loaded the data, let's say that we are in another state. Let's say that we have the status, which is called data loaded, or whatever name we put here. Now, what should be the data over here? Well, certainly there should be some data being loaded, and let's say that that would be the T array. Let's say that T could also extend an object, whatever, it just doesn't matter. And what should be the error in this case? Well, if we have successfully loaded the data, then there is basically no error at this point. So we're basically done. And finally, what would be the other one, the other state that is here? And Copilot is already suggesting me that, yeah, if the state is an error, then we should basically have the error over here. And bear in mind, this is not optional. And this one is also not optional. That's the whole point. If we are in the error state, then, well, we need to have some error. Of course, if we don't have the error of type error because we're working in JavaScript, which lacks, let's say, some type precision, in some cases you might, replace error with unknown or whatever relates to basically type handling and type safety. But still, if we are in the error state, it's not that we could have it, but we might not necessarily have it, and then we have basically a runtime bug, because, well, here, dear everybody, all possibilities are allowed. And if we think about it, how many different possibilities of error property value could we have? Let's also group it, because we could have like infinite amount of different, values of errors. But let's say that either we have the error or not. So that would be 2. For the loading, which is Boolean, certainly that would be either true or false. So again, 2. And here with the employees, let's again limit it down to either we have some data or we have no data at all. Never mind what this data would be, just having or not. Again, 2. How many different possibilities do we have in total? And the bad news is that, everybody, in total, that is 8, because that's 2 multiplied by 2 multiplied by 2. So maybe that's not such a bad information, but the problem is that only 3 of them are valid, because we are loading the data, or an error occurred, or we have successfully loaded the data, right? So only 3 of them are valid. And if we basically subtract 3 from 8, then we can see that most of them, the majority of the technically viable states, so they are technically possible, they are, dear everybody, invalid. And the whole point, and hence the title of the presentation, is get rid of impossible states. So what would be an impossible state? Let's say we have the employees and we are still loading and we have an error. Would TypeScript yell at us if we walk into such state? No. Why? Because these properties are independent. And it doesn't make any difference whether we consider properties of an object or basically variables, which are basically put somewhere like in React hooks, just variables in a single scope, or even not necessarily in a single scope, but yeah, they're basically independent. And what we want to do is we want to make them dependent on each other. For instance, if we are loading, then there is no employee and there is no error. And here, if we wanted to actually instantiate a thing, let's say that would be the, let's say, loading, of type loading state, of course, then we can absolutely instantiate what is the, that we have the status loading over here. But if we wanted to add some additional properties, let's say somebody would like to make a mistake for some reason, was about to make a mistake, TypeScript will kick in the excessive attribute check. When TypeScript is given an object literal, it will yell if we're trying to assign a literal. It will yell if there is anything excessive, like kind of goes beyond the required properties. So we could say that in some way this goes against polymorphism. So this is kind of an exceptional situation, though this check is very, very useful. So we need to define what is absolutely needed, because basically a required property needs to be there, because it's just, like in all other object-oriented languages. But TypeScript is going to also yell at us if we want to try to create something more. Again, if we want to, let's say, create the successful property over here, and we assign the data loading, data loaded over here, and we would forget about adding the required data property, then TypeScript is going to yell at us here as well, obviously. So we have type safety in terms of our state machine. And why should we care at all? Let's say, dear everybody, that we wanted to have a ng on init And let's say that instead of putting this inside the, I'm just going to quickly use some Copilot suggestion over here. We'll take a look at this in a while. Instead of just creating this stream within the constructor time, we would put this into the ng-on init. Now, dear everybody, if we think about it, let's also replace that. We're just going to use the this.employees stream. Now, if we get the response from the server, what we should do is, of course, we should update what is the employees property, what is the loading property. What Copilot didn't suggest is that most probably we should also clear the error that should be undefined. Or how do you think maybe we should clear the error before actually walking here? What would be a good idea? Or if we have in RxJS reactive streams, we have the next error, but we also have the complete event handler, right? So what should we put here? How about the employees? And how about the error? How about the loading, etc., etc., etc.? That's the whole point, right? So that's the point. I hope you can clearly see that when we, yeah, what should we do with this one when we complete? Maybe something, maybe nothing. If we have an error over here, well, maybe we should clear it undefined. And yeah, loading should be certainly false in this case. I hope that until now, you can clearly see that this example is so simple, but it gets messy, right? Actually, if we wanted to do it right, then we should, like Too Long Didn't Read, we should do as much cleaning here initially and not to do it here. But what I hope I managed to make it clear is that if you just forget about one line in a very specific place, or you put one line excessively in a place, then you introduce a bug. And that's the primitive obsession, because we need to handle every single damn line separately. And this is difficult to manage, and this is difficult to reason about. So what is, dear everybody, the alternative? So let me just quickly finish this, this thought, and I'll just uplift the state over here, and we'll just use the loading state over here, and we'll replace these three properties, which we don't need to use anymore, and use a state machine. So what is going to be the, let's say, employees state, or whatever we want to call it, employees state? This is just going to be the loading state of employee. And now TypeScript will, of course, require us to think about, okay, so what is your initial value? Well, some people like to introduce one more state, which would be explicitly initial. Maybe in some cases it does make sense, though we can just make things slightly simpler by instantiating that this is actually the loading status. Now, what would happen over here? Let's say that this was not even the ng-on init, but that was basically a reload method, and our ng-on init lifecycle was basically using the this.reload. So all in all, our reload method could be using, could have been called multiple times. So what we're going to do is basically to do the employees.state equals status loading. Now, again, if we want to add something that is excessive, TypeScript is going to yell at us. So imagine all changes that you are going to not to do now when you're just writing the code, but all the people who are going to maintain your code base in the future. These are all the bugs that they will not make. And I think it's really cool. And this pattern is so simple. Like, we're just using a TypeScript object union. If you know what is a TypeScript object union and how to deal with discriminated unions, that's basically it. So yeah, this would be basically the step over here. Now, when we get the data, then we can get rid of all of this crap. And yep, status, data loaded, and the data is basically employees itself. when an error occurs, what we want to do, that would be employees. Oh, now I can see I made a small typo. That would be the error, and we do have the access to the error. And now, do we need to know what happens when it completes? So it would make a difference for us if we want to differentiate, because the next from complete if there were more than one responses. So at this point, we can basically move it away. But what is important, dear everybody, we are not responsible for replacing single property one by one. What we're actually doing is we are replacing the whole object. And now, how can you make sure that you clear the error when you move from one state to another state? Well, if we are replacing the whole object, then we know that whatever existed on the previous object, it doesn't exist now. And that's the whole point. Like, it automatically basically gets done. And the final thing, the very, very last thing that we can do here is, forgive me the compilation error over here, is that we can basically check, like, when would we be able to actually display the data? Well, we can just check whether the employees.state, employees.status is loading. So if this is loading, yeah, but this is the other loading. So if this is loading, then basically the employees sorry, not loading, of course, not loading. This is the data loaded one. Data loaded. Now we have the access to employee state.data, and here again employee state.data, and yeah, we're done. So what we can see over here is that Angular compiler is using TypeScript compiler under the hood. So we also need to, before we actually make use of any of these properties, we need to check whether they exist. So imagine all the changes that you would need to do here. They're basically guarded for type safety. So that's all I wanted to share with you, and I hope that I managed to kind of either make you interested in giving it a try, or reminding yourself that if you just remember to use a TypeScript object union, then you're good to go with state machines. Very last sentence is that what we are capable of doing is to make the states themselves type safe. So we can clearly say, let's say that if this is the loading, then from loading, we can walk into the data loaded. And from data loaded, we can, again, reload the data. So we are in the loading state. Again, walk into error. If error occurs, then reload again, etc. So what is type safe is basically the state data, the state definitions, but the transitions. So we can basically check the correctness of the state data within the compile time. As we can see over here, it's compile time type safe. But when it comes to the transitions, well, the TypeScript unions do not care about transitions. In this case, we would have to reach out for a specialized library like xstate or any other libraries that you might want. So in very complex scenarios, reach out for a specialized library. If you don't have a very specialized example, just use a TypeScript union. Thank you very much.
Wow, thank you so much. That's a really cool pattern. I've not seen anything like that, and just using just TypeScript. I mean, that's just really cool to put those kind of guards in. Have a couple questions. I have one for myself because when I watch talks like this, I realize that I really know nothing about TypeScript. So on your union, the type loading state, just curious about like the syntax. The first pipe operator there, is that required, or is that just kind of used to line up your text? And
the latter, just to make them look similar and also make them slightly easier to read. And some freaks like me, when I introduce changes, I would like the git diff to be as short as possible. So now if you add them, replace them, etc., you don't get the kind of white space-ish things that would kind of mess up with your git diff. But other than that, you can basically treat it as if it was transparent. It doesn't matter. But I think it even kind of looks more cool because you could think of it as if it was just an enum of pattern matching kind of structures.
Mhm.
Kind
Yeah.
of.
Yeah, that's cool. No, I
So it's
hadn't used that,
transparent.
so it's very interesting. Yeah, so speaking of enums, we had a question from Michael Pierce. Is there any way to use a string enum for the status, or is it more normal to use string literals?
Okay. In most cases, it doesn't matter which one you use. So if the question is what is more common or what is more widely used, I would say it depends on whom you ask. But I would say when it comes to design, software design, what matters is what are the, let's say, mistakes or troubles or bugs or I don't know, nasty situations that you want to defend your code from, that you want to make it kind of irresistible or non-vulnerable, etc. But this is kind of something, a matter of preference, and I would say like it doesn't really matter. Like if we created just an enum, it would work exactly the same way. Because the thing that you need to have here, it basically boils down to using TypeScript discriminated unions. So in a discriminated union, you need to have all the members to provide this property, so-called discriminant property, and they all need to have exclusive values. So this would be a non-exclusive value because data loaded is exclusive with error, but they are not exclusive with string. So this will kind of, and basically, as you can see, it breaks. But if only you provide a specific value of the enum, not the whole enum, but a specific value, you're good. I think, like from my experience, this is what I have seen way more often, but it's really irrelevant
Okay, great, good to know.
in the long run.
Yeah. We have another question from Anthony Blasco. They're asking, how do we use state machines in a project that uses NGRX, or is this something that this would be used instead of NGRX for simpler use cases?
So something that I haven't mentioned is that this is framework agnostic. As you can see, it plays with Angular very well, but this is kind of whatever framework you're using and whatever library for state management you're also using. So you're perfectly fine to shape your reducer or shape your state object, whatever, to include this one. So we do that with Redux, we do that with NGRX, we do that whenever we need. Basically, imagine that in your NGRX reducer or any other reducer, whatever tag you're using, that you would basically have a bunch of properties or variables that are technically independent. That's the source of the problem. Because if they're technically independent, then they could live their lives kind of independently on each other. So what we want to do is to basically make them dependent. So in NGRX, I would need to remind myself, but I'm pretty sure you can pass, either you pass it explicitly, or maybe you can pass a generic type that would basically say that instead of basically listing what your properties are on the state object, you could basically say, oh, like this is my type, or this is a type of my property that basically becomes a part of the state object. So you're absolutely good to mix the two. The whole point is there. And by the way, what would be an action in this case? An action in an NGRX store would basically be to make a transition from state A to state B, which would be even more awesome to kind of combine the approaches. So absolutely yes. By the way, there is also a thing that is called Angular Query that is based on TanStack Query, and they're doing exactly the same thing, though instead of just 3 properties, they're having something more like 20 properties, but they do exactly the same thing. And instead of 3 states, they have, I believe, 6. So they're just, more edge cases are covered. But apart from that, it's this thing, literally within the sources.
I love it. I know that I'm going to be stealing this very soon. And I've seen some others in the chat saying same thing, how cool this is. So thank you so much for sharing this. This is really, really cool information.
Thank you very much, and hope you will find it useful.
Yeah, thank you. And we'll let you go and get some sleep. Hopefully the baby will let you sleep for a little while.
Thank you very much.
Thank you. Have a great night. All right, I'm going to hand it over to McKenna and Deborah.
All right, thank you. So welcome, Deborah. Thanks so much for joining us to give your talk. So a little bit about Deborah. She is a software developer, Pluralsight author, speaker, Microsoft MVP, Google, GDE, and YouTube content creator. Her content on YouTube focuses on programming and web development, specifically for Angular, RxJS, NGRX web development, TypeScript, and C Sharp. Well, I'll turn it over to you. Just a plug. Highly recommend checking out Deborah's YouTube channel. We went ahead and threw it in the chat. She has over 100 videos if you want to get started, and sounds like she has a new video dropping soon. So with that, I'll turn it over to you, Deborah. Thank you.
Okay, so we're going to talk about block syntax and signal inputs. McKenna did a really nice job of introducing me, so I don't need to say that again. But I just recently went to Egypt, and it was the coolest thing. If you have the chance to go, it's a very fun place to learn stuff. All right, so we're going to cover 3 primary topics here. We're going to look at 6 interesting things about if blocks, 8 fun facts for for blocks, and signal inputs, outputs, and model inputs. I sort of grouped all of those into one topic, basically. So starting with the if syntax, if you've spent any time with Angular at all, you are familiar with this ng-if directive. But starting in the newer versions of Angular, we can now use the if block, which lets us be more JavaScript-y, TypeScript-y with how we define our templates, which is really nice. And one of the best things about it is it gives us a lot more flexibility. So we can do things like @else. So here I've got the if block and the else, and then here is my result. So if the number in stock is 0, it displays out of stock. Otherwise, it displays the price for it. And to add to that, with else and if, we also have else if, and that was practically impossible to do with *ng-if. So we now can do an else if on here. So we have if the number of stock is low, it displays it differently. So that gives us great flexibility with regard to how we lay out our templates. The other cool thing is because this doesn't require being in an element, the *ng-if was a directive attached to an element. The block syntax is not attached to any element, so you can actually put it anywhere. Here I've got it right in the middle of my header, and so it comes out just like this. So if you have a person defined, it says for and that person, otherwise it just has the title. And so that's something that's cool that I wouldn't have even thought to try, but I just needed it. And I'm like, oh, I'm going to try that. So that's another cool thing about the block syntax. The block syntax, the if also has an as clause for backwards compatibility. So here I can read the signal once, define it as a different variable, and then reference that variable. However, I'm not going to read this all to you, but you can read it. This is from one of the members of the Angular team, as is effectively a local variable declaration. And by using as, you lose reactivity. The child template might not update because it isn't doing the signal reads itself. Now, I played around with this for quite a while, and this does all seem to work with as now. But as you've probably heard, the Angular team is working on a lot of the change detection, and they're making quite a few changes, and they're potentially doing signal components. So at some point in time, if you use the as clause, it quite possibly might lose its reactivity. So something to keep in mind. The last thing about the star ng-if is that you used to have to import it. Now with the new if blocks, you no longer need to import it. It's built right into Angular. So if you're doing standalone components, you don't have to do this extra import step. So that's cool. All right. For syntax. So the for block is also pretty cool. It replaces the star ng-for directive, and this looks like this. So it's similar, but it then gives us still that JavaScripty, TypeScripty kind of feel for our template. So notice here that it is just displaying my table. But the track is required. And notice also that it doesn't have a let anymore. This used to require a let keyword for the star ng-for. Let's talk for a little bit more about track. Track, the whole purpose of that was to uniquely identify items in an iterable collection to make change detection more efficient. Track by was available in the star ng-for, but people weren't using it. It wasn't required. And it was kind of a pain to use because it required passing a function. You couldn't just pass a value. And so it was a little bit more work. And the Angular team found that some companies ran into really large performance issues because they weren't correctly or appropriately tracking their items in their big lists of things in their iterable collections. So that's why they made it required. So you can either use a unique ID if you have one. Otherwise, you can use the reference to the object, which would also be unique for each object. So if you don't have a unique ID to use, you can use that. You can also still use a function. So for backward compatibility, you can specify a function in the track and then write whatever code that you needed and return a unique identifier. The other cool new thing that was not in star ng-for is the @empty. We always had to add an extra if block or if asterisk ng-if around it if you wanted to have something that displayed if the list was empty. Now we just have an empty block. So here in my example, I've typed in a filter. There are no snacks that match that filter. Can't believe no snacks that are candy. But anyway, so it displays no snacks available that match the filter. Like the star ng-for had, it does have a dollar index. So you can use that. So here I'm adding 1 because the index is, as always, 0-based. Users are basically 1-based. So that's what the +1 is doing here to display the index numbers on these. There's also a first and last. So if I wanted to do something special on the first and the last, here I just used a different class. You can do that. More useful, though, probably is an odd and even. So you can do things like stripe your rows, do different classes based on the odd or even. So really kind of fun stuff that you can do. There's also a dollar count. And as far as I could tell, we didn't have anything like that in star ng-for, but it is available in the for block. The kind of little bit of odd thing about it is that variable is only available within the block. So if you wanted to display the count, like snacks parent 5 or 2, 4, I have 6, I guess, you can't do that because it's outside the scope of the for. And anything you put in the for, if you display it, it's going to repeat it for every item. So I don't know how useful that is. Here I'm using it, so if I have more than 4, it scrunches my display a little bit to fit more on a page. But that's also available. And as with the ng-if, we do not have to import the new for because it's built into Angular. Okay, so that's the if block, and the for block, that's new as part of the block syntax or control flow that's relatively new in Angular. One important thing to note is that there is an automatic migration available. It uses an Angular CLI schematic, which means it's ng, part of ng-generate. So ng-generate at Angular/core control flow, and it will go in and change all of your at star ng whatevers to at if and at for. I've tried this on several of my applications and it's worked great. So if you're interested in taking your large application, it also has an option to just do like a folder at a time. So you don't have to do a huge application-wide change all at once if you don't want to. Alrighty. Signal inputs, outputs, and model inputs. One of the things that I've seen people get confused about these is to understand when you can actually use them. These are only available for communication between a parent component and a child component. So if you're not using parent and child components in a particular place, there is no use for signal inputs, outputs, or model inputs. They're, as I said, their sole purpose is to provide that communication between the components. What do I mean by parent? Well, you can kind of think of your entire component as the parent and a component it uses as a child. So that would be the app filter component, which is this guy here, and the parent is my outer part here. Okay, are we good there? All righty. So signal inputs. Signal inputs allow us to use this keyword input. Instead of having to have this ugly looking kind of decorator on our input properties like we've had before. So this code is actually in the child component. The child component is basically saying, I need your input here, and is asking the parent component to provide a value. The parent component then provides the value by way of property binding. So the parent says, here it is, here's the input that you need, and I'm giving it to you by binding to that particular property. Now, these new inputs, as its name implies, are signals. So this is putting this value into a signal. So if I have current employee in a signal in my component, my parent component, I read the value out, pass it to the child component, and then it creates a new signal with that value. Okay. The syntax, it has a couple of options. You can call .required, and required input means that the parent absolutely has to pass something to it, or you'll get a syntax error. The transform allows you to transform the value between the parent and the child. So whatever the parent passes in, the child or the this code will convert it before assigning it into this signal. There's also an alias. So if your parent, whoever's developing your parent code, is used to referring to these things as something else, like some companies use partner instead of employee, that it can do that. And then the parent uses property binding to bind to that name instead of your other name. Okay, next is the output API. So the output API replaces the ugly output decorator that we had with this new event emitter syntax, and it wasn't very nice. So the new output syntax is just output and then the type, which is the type of data that we're outputting. And it's kind of the same as what we had here. So in this case, this is still an event, but it's not an event emitter. It's an output emitter ref, but it is not a signal. Sometimes you'll hear people say an output signal, and it's really not an output signal. It is still an event. Okay. So the child will say then something like, I need to give you something, because this is from the child out to the parent. And the parent says, great, give it here. I'll process it using this method. And so then you access it with $event. So this code is the exact same as it was in prior versions of Angular. It's just this output syntax is changing. This then uses event binding. So it uses the binding to this name here in order to sign up to receive those notifications. The syntax for that, the output does not have a required option. The parent can listen or not listen to these events, but it does have an alias. So I could do match changed, and then that would be the event I would use in the parent to talk to the child or to receive the events back from the child. The coolest one of all, and my personal favorite, is model input. We didn't really have anything like model input in earlier versions of Angular. And the syntax for that is quite simple. It's just model, and the model is a signal. So the child is like saying, let's share this value. And the parent is saying, sure, put it here. And I'll let you know when the value changes so that you have it. And you let me know when the value changes so I have it. And these are both signals. And so they're using the signals to keep the values in sync. And notice here then, I can use two-way binding. Now you could do something like this in earlier versions of Angular if you were careful how you named your input and output. If you named them exactly correctly, similarly, then you could actually get two-way binding to work. But it wasn't always super intuitive, and it wasn't very obvious how it was working. This is very straightforward as to how this is working. It's very simple. I don't have to emit any value. It's just hooking these two values together through two-way binding. Okay, so note here that we are passing in the signal, not the value of the signal. So you notice I don't have the open and closing parentheses to open the box basically and pull the signal out of the box. So the syntax for this, it does have an option to be required, and it does have an alias. It does not have, excuse me. It does not have a transform feature, and that sort of makes sense because if it came in and transformed, then it would be changed, and then it would be modifying the other one, which would then notify it was changed, and you could get into a circular issue there. So here again, if I use an alias, I bind to the alias in the parent to the child. So to summarize, so here's a filter component that has an input property, an output property, basically, that is our event, and our model property. So our component, our parent component, passes in to the employee because it's the input. The output comes out by way of an event, and then I get the data through that $event. And then there is my model required. With that, I have a demo right here. Okay, so this is basically the code kind of you saw from the slides. Here are my three properties. I've got the input, the output, and the model. So here in my filter by, if I have, whoops, hit the wrong key. If I have no filter, I get the entire list. If I type in nut, I only see the nuts. And if I type in capital nut, it still sees all the nuts unless I check that box. Then it has my at empty text, no snacks available that match that filter. So the only other code that I needed in here for this to work is for the change event on checking this match case. When that is changed, it emits a value into the output. And again, that's very similar to how we had to do it with the output decorators. So it's passing the value of whether it was checked or unchecked. Then for the parent, here I am binding to the employee, which is reading the signal out and passing the value from the signal. For the filter value, which is my model, I'm passing the signal directly. And here I'm using event binding for checking the flag. In the component then, here are my signals. And here is the event that I am running when the user checks that checkbox. When I get notification from the child, it runs this code, which sets this signal. And then I'm using a computed signal to filter my list correctly. So if the match case is checked, it does the filter one way. If it's not checked, then it does it another way. And the last thing I have then are some links. So here you can follow me on Twitter or whatever they call it these days. My link to these slides are here. I have 3 separate demo apps that are all in StackBlitz. One that demonstrates the if block, one for the for block, and one for these signal inputs, which includes the output and the model, which again is my favorite. And if you are so inclined, I'd love to have you join my YouTube channel. And I'm always looking for suggestions too, if there is a topic you'd like to hear more about on my YouTube. And with that, I want to thank you so much.